Good afternoon, ladies and gentlemen. It's good afternoon here in Los Angeles, California. It's February 2, 2022. My new topic or my new discussion on my electronic on my channel that involves that's related to electronics is the use of an induction stove. This is an induction stove. Okay. The use of this is actually for cooking. We could either use gas, electric. This is electric. The power consumption of this is electric. But the manner in which it will heat up the food will be different. Okay, so I will discuss that one today. Inside this induction stove is actually a coil like this. It's a coil, right? So if we try to run a current in this coil, okay, the current will go around, right? And by the theory of the so-called production of induced voltage, if a coil is being run with the current inside it, there should be a magnetic flux around it. A magnetic flux. Magnetic flux is something like this. I will show you how. It's like this. If this was the coil and we run a current through it, whether we like it or not, around it there should be a flux circling. Okay? That's the nature of this. If a coil is run with the current, there should be a flux circulating around it. And that's the one creating a voltage to whichever conductor that goes near it. Right? Meaning, if we run a current through this, there should be lots of flux around this, all of this. Lots. So if you place any ferrous conductor near it, okay, that ferrous conductor, an iron, something like that, the material thing is iron, okay, there will be an induced voltage in it, and anything you place on top of that conductor will heat up. Actually, it's actually our cooking thing. Right? The bottom portion is iron, this one. So if we place on top of it and we run current through this, there should be lots of fluxes on this, and it will induce voltage on the bottom portion of this. This will heat up. Okay? As it heats up, it will cook the food inside. So actually, there is no direct electricity coming to our food. It's just the magnetism or flux that's bringing out the induced voltage on the bottom portion, so it will cook the food. So the one inside this induction stove is something like this. There should be something like this. So the number one requirement, there should be a coil. Okay? This principle is actually something like in the generation of voltage. In the generation of voltage, for those who do not know about generation of electricity, if this is the North Pole and this is the South Pole, the Earth actually got a natural magnetism that emanates from the North Pole that goes to the South Pole. So actually, our magnetism is the one moving. So if you put a conductor perpendicular to that magnetism, it will induce a voltage. There should be a voltage on this. And actually, that's generator actually. That's the principle of generator. For this case here, the one moving is the magnetism, the flux of the earth, or the magnetism of the earth. It's moving, right? It's going like this. So as it strikes a conductor that is placed perpendicular to it, it will induce a voltage. Whether we like it or not, if you get your voltmeter across this, there should be a voltage across it. It's alternating. And actually, that's the principle of a generator. For a generator, the magnetism is steady. It's not moving. The one moving is the armature of the generator. Why it's rotating? It will rotate, so it will cut the lines of force. As it cuts the lines of force, there should be an induced voltage on the winding of the generator. So if you get your voltmeter and measure the voltage across its terminals, as it rotates, there is a voltage. And that's the one we are using. Even in the big generators of power plants, the principle is also same as like that. Okay? So actually, to create an induced voltage, electrically speaking, there should be magnetism, there should be a conductor. If these two are present, there is an induced voltage. Like in the induction stove, as we inject current or as we pass current through the coils, okay, it generates a magnetic flux, and that magnetic flux will generate a voltage underneath the cookware. But the bottom of the cookware should be made of iron for the current to be maximum. Other materials, it's not good. So engineers now know that for the heat to be maximum, the bottom portion of our cookware to be used for the induction stove should be made of iron, cast iron, ferromagnetic material. The power circuit of an induction stove is something like this. It's like this. The one inside. We got the power circuit. We got the control circuit. Then next to the control circuit is the coil. The one I've shown you. The circular thing. Okay. So you inject a voltage here. The power circuit, it could be a rectifier or an inverter. Okay. For the control circuit, we need a DC voltage. So actually, we need a rectifier here in the power circuit. There should be a rectifier over there. That DC voltage will control the control circuit, and the control circuit, the voltage that's needed for it is not alternating current. It should be direct current. What's the use of the control circuit? It's used to control the timer and the temperature setting of the induction stove. Okay, there should be a little computer. It's not a complicated computer. It's not so complicated. For that controller to control the temperature setting and the timer setting. It's not manual. It's actually we are talking digital over here. It got a little computer. This one got a little computer. Okay. Power circuit, control circuit, it's the coil. So you plug it in. You program the temperature setting by using the control circuit. You program the timer setting by using the control circuit. Okay. Put your cookware on top. That's it. Okay, I will show you how this one will work. Okay. It will not take so long. Okay. I've got my energy meter over here. I plug in my induction stove. I plug into the convenience outlet. Right? I will switch on. I will switch on the induction stove. Okay, I will program the temperature setting now. I will just set the cooking temperature of this for 80 degrees centigrade. So this is 6, this times 10, or 60 degrees. Or we may 80 degrees. It's 80 degrees. 80. 8 times 10, 80 degrees. Tapos I will set the timer for 5 minutes. Okay? As a bonus, to let you know that the top of the induction stove is not hot, it will not burn anything on top of it, I will place a dollar bill over here. That's a dollar bill. Okay? This is an aluminum cookware, okay, in which the bottom portion is ferromagnetic material. It was really designed for induction stove. It got water inside. We put this part, okay, we put it on, okay. We set to 80 the temperature. I will set the timer for 5 minutes. Meaning, I will try to heat up the water inside for a temperature of 80 degrees centigrade within 5 minutes. Let's try to see. I put a dollar bill underneath to show you that the bottom portion is not hot, meaning it will not burn anything. We are cooking now. We got a dollar bill underneath. The cooking temperature is set at 80 degrees centigrade. The timer is 5 minutes. The current consumption, I have read it from our energy meter, it's around 10.26 amperes. $10.26 amperes. $10.26 times 117. The consumption of this induction stove for the meantime is 1,200 watts. 1,200 watts. I set the timer for 5 minutes. Let's see if the water will boil after 5 minutes. I will try to peep inside. It's getting hotter. It's hot already. It got some bubbles, see? Got some bubbles. That's only 2 minutes. You see how the principle of induction stove works? There is no direct heat that will heat up the cookware. It's just the magnetism underneath. It penetrates the ferromagnetic material under the cookware, okay? If it penetrates, it induces voltage, okay? Then that's the one that will heat up the food inside. I will try to fit. See? It getting bubbles inside. This is a live demo, ladies and gentlemen. I put a dollar bill underneath the cookware. I will show to you that it will not be burned even when we are cooking using this induction stove. Even the induction, the top portion is not hot. It's not hot. Of course, the cooking thing is hot. Or the one inside is hot. See? See? Got smoke on it. So actually, there is no direct fire that heating up the cookware, right? It's just the magnetism. It's the magnetism emanating from here. That's the one heating up the cookware. It's the magnetism. It's different from the ordinary electric stove. It's the magnetism. So actually, there is no fire. No fire. This is the one hitting the bottom of the cookware. The one inside. We are done. Okay? Let's see if it's hot. This is hot, ladies and gentlemen. Actually, you can make coffees now. It's hot. See? That's 5 minutes at 80 degrees centigrade. Okay, I will try to remove this one. I will shut it off. Okay? I shut it off. And to let you know, okay, the dollar bill I put underneath the cookware while we are cooking was not been burned. Okay? It's still alive. It's still a pure money. It didn't get burned. But if you use the electric stove, put it underneath the cookware, oh, it's gone. But for induction stove, no matter how long you are cooking, put a dollar bill, it will not be burned. Okay, ladies and gentlemen, I think that's just more than good enough demo for this afternoon. At least we now know the principle of an induction stove. Induction stove cook the food on our cookware by using magnetism. Induction, okay? Induction meaning if you pass electricity through the coil on the induction stove, it will create a flux, and that flux will induce a voltage underneath the cookware, okay? As a voltage is induced, the induced voltage will be the one that will heat up any food that's put inside. That's the principle of induction stove. So for you guys who don't know nothing yet about the principle of induction stove, that's the real thing that's happening inside an induction stove. Actually, the induction stove is, it's not hot. A little bit hot, slightly hot. So actually, induction stove, you could use it inside your office maybe for heating up some water for coffee. It's very clean. It's easy to clean. No sputter. Okay? That's it, ladies and gentlemen. This is just a video for your information on the principle of induction stove. Okay? So if you've got any question, guys, to let you know, I put this dollar bill while we were cooking. After cooking, the dollar bill didn't get burned. Okay, this is for now. Good afternoon, Los Angeles. Thank you. This is David de los Reyes.